Everyone, thank you so much for coming. So, as we promised you before, that we will use the first semester to talk about Python, and the first half of the semester to talk about Python, and the second half we'll talk about data science. All right. So from today we'll start talking about data science. Actually, from next semester. My plan is will be different, so I will cover Python only in 2 weeks, and it will be a responsibility of the students to go over Python as a whole, and then we'll start with data science. I might have 2 full day weekend, 8 hours each, and we'll finish Python in 2 weeks, and then we'll jump into the data science and machine learning. All right. Maybe you have noticed that in the exam that I don't have time to go over the exam. If I have to, then I have to find other time to call you and to go over it. But maybe you have noticed that the questions are general questions. Okay, so any person who has a good and solid background in programming will be able to score 100 in that exam. It just loops, variables, running the code, understanding the code, how the code process, whether the questions are written in Java or C++ or Sharp or Pascal or Fortran or Python. Okay, if you have the concept of programming, you will find it very easy. So all the questions, most of the questions, very few questions, they needed you to know Python, right? When I talk, for example, about a pop in a list or insert in a list. Yeah, of course. I mean, simple questions like that you should know because you're doing the homework, right? So you should know the code. Say given at the end. If you know the idea, okay, you have the whole Python with you in a sheet, right? Cheat sheet, right? So it's not that you require to memorize the sentences and all of that. You have it with you. You learn a lot, right? So if you are able to understand the idea, again, you'll be able to write it in any other language, including Python. So I focused mostly in the exam. I hope you agree with me on the concepts. So if you find the exam is difficult for you, or you did not score very well, then you have to work on your concepts. Okay, and that's what I tried during the semester to build the concept of programming as much as you can. No one can make you a good programmer. If there is anybody can make you a good programmer, it's not me. I'm not talented enough or qualified enough to make anyone a good programmer. Okay? Our goal is to put you on a track. We go through the material. We'll give you homework, weekly homework that you need to do by yourself. Spend 5, 6, 7, 8, 10, 20 hours every week programming. You will be an excellent programmer. All right? Finally, midterm is a midterm. Forget about it. All right. You have seen what I wrote, so still you could get A range in the class. Okay, if you do very well in your second exam and in the project and in the homeworks and the rest of the semester. All right. So still, it's a fresh start right now. Okay, we're gonna start data science, and I promise that anybody doing very well in the rest of the semester, then the first half or the first part of it will not change anything in the equation. Okay? It's a new start. Okay? If you don't believe me, just ask the students to course with me before. I don't care, again, I repeat it one more time, I really don't care how you start. You took this course because you don't know, right? All I care about is how you end it. How you end it. If you, at the end, you're knowledgeable, you know how to program, and you're good, okay, I'm happy and you'll be happy. Fair? Okay, I think I answered the question before somebody asked. Alright, so we're gonna go to into packages. And last semester I started right away from Panda. I'm sure you have gotten the book, right? It's a very good book. Okay, but I did not have time to cover NumPy. Okay. So this semester we'll cover today for NumPy, and again it's a huge package, the whole programming language. Just I need to introduce you to it, and like any other package, you'll learn from now on is huge. You could have a whole semester learning pandas and more, and to learn NumPy, and because they are really huge packages, you could do a lot of them. In short, NumPy is like MATLAB. Anybody used MATLAB before? No? Okay. So it's like a programming language, you know, that you could write using your Python, and you could, you know, what we do with MATLAB, by the way. Solve equations. That you're solving equations, right? Okay. What other main field of MATLAB we use it for?
Graphing.
Graphing.
To
Okay.
map it.
Okay. How about vectors and matrices? Okay, so okay, you know, like matrices multiplication and you know all that. So that is basically, you know, what is, you know, mostly it will work with vectors and matrices, and everything you could do in MATLAB supposedly you could do with Python. Okay, so why we use matrices for example, or vectors, to solve equations, right? To solve differential equations, for machine learning, for deep learning, for image processing, signal processing, etc., 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 etc. So all of this you're gonna need. All right. So I mean, I don't know what reference you need to use. So myself, for example, I picked this. I was working on this last week. It's a good book. I mean, you could get it. I think it's from Packet. I remember that I bought it for $5. The book. Okay, the online version. Okay, so I'm not sure that there was a deal. So I mean, I don't care what book we're gonna use. Actually, today I was planning to cover from here. I think I created a PowerPoint from this book. I could share it with you later, but I will cover today for change, only for change, from the internet, from one of the websites. Okay. Anybody use IPython before? IPython, I'm sure. Raise hand if you used it before. All right. So did you install it? I put instructions for you to install it. So IPython is an interactive application where you could. Okay, so all you have to do, for example, so whenever you would like to create your files, I think I have my own files somewhere in here. I created a folder called Notebook. All right, you go in here. Okay, you go here. Write CMD, for example. It will open it for you in the same path. All right, and you know, a place where you keep your. So you say Jupyter Notebook. And can you see? Well, it's too small, right? Go in here. Properties. I think 24 million. Is it more? Good. Okay. So a Jupyter Notebook, and we'll open it for you in a website. Okay. So let's go to Chrome. This one. So these are the files are in that file. You could create a different. For example, you could go a new one. You could open a current to try to create one new one. So a new one using Python 3. And here you go. So in here you could write your sentences. Okay, you know, and execute them one by one. Okay. Of course, for example, okay, you could in here, when you go to here, you could write your code, and also you could write a heading. For example, okay, in here I would like to write, for example, okay, NumPy tutorial, whatever. Okay, no. And to execute it, usually you could say run, or just shift enter, and you know, it's like a title, you shift enter, Alright, so quickly go over the menus in here. I hope that you had some time to play with it yesterday. Okay, file, so you could open a new notebook, you could open a new note using Python 3, you could open existing one, you could make a copy, you could save, etc. For the editing here, okay, so you could like working with the cells. These in here we call them cells. So for example, when I go in here, say print, for example, print hello friends, for example, and shift enter, or I could go in here to cell and run cell. It will execute it, or in short, shift enter will execute it for you. All right? Okay. So to insert, okay, to have a new one, shift enter a new one in here. For example, you could have whatever sentence. Right? The nice thing about it also, you don't have to import numpy and sumpy and pandas because like part of the package. Okay, but you could. So because today we're working in pandas, so import, okay, numpy as mp. It's kind of a standard way. As mp. Okay, it's imported now. All right. So we're gonna work with numpy. All right. So for example, if I need to create array, what are the iterables we worked with? We worked with list, tuple, dictionaries. What else? Tuple, dictionary, list. Anything else? Strings maybe, right? All these iterables. So in here we're gonna work with arrays. We'll go to arrays. So if to create array, okay, so equals, for example, okay, array range, for example, range, okay. Anyways, so we'll come to it, okay. So in here you could have a code in the cell, you could have a markdown. I have no idea what's markdown. On row ABC convert, I have no idea what's that, just try it out, okay. Anyways. So that's what we're gonna use today, alright? Alright? Always you could use, if you don't like it, you could use the typical IDE. I like PyCharm myself, that's what I use mostly. If you like the IDLE or whatever, if you like Microsoft Office, whatever you like to use, you always feel free to use whatever you would like to use, alright? Okay, let's try it out for today for change. Okay, and some students told me they liked it, asked for it, so we'll go. Okay, so now for the tutorial today, if you could go to tutorials point, all right, and it has a whole tutorial about numpy. I will go over it. There are so many tutorials, and here we're gonna cover the basics. Again, I mean, the only way to know how to use it is to really try it out. So it will give you like what are the prerequisites for it. Okay, very simple to install it. Just you have to pip install numpy, alright, and pip install numpy. That's what it is, and then you have it. Okay, of course, you always could download the binary packages. There's no need for that. And this is how you download it if you are using like Linux machines or Unix machines. So that's all easy. You don't have to worry about all of that. Alright, so when you look at how is it stored, okay, the most important object defined in NumPy is the n-dimensional array. So in here we're gonna take with n dimension. N means multiple. It could be one-dimensional array, it could be 2 dimensions, could be 3. Believe me, it could be 5, 10 dimension. All right. So it could be very complex computation you could use with NumPy. In the list, how many dimensions you could have? Maximum 3, right? 3, A, B, C. Okay, and here you could have like 10 dimensions. Okay, multiple dimensions. All right, ND dimensions. Okay, and we call it ND array. Okay, N for N, multiple means array, one N dimension array, and it will describe a collection of items of the same type. So in a list, if you remember, or dictionary, you could have in one dictionary or list like different types. You could mix float, you could mix integer, you could mix all of these in one type, right? In NumPy array, it has to be the same type. It has to be the same type. And each element in the array of object, it has a data object or D type. We'll see it in a second. All right. So the way is this is the ND array. All right. So the ND array will have a header, and the header will tell you what are the data type for all the elements of the ND array. All right. And each element also, when you look at it, will have a header. Will have a header. So basically now in the array, or we're dealing with the data in the memory. They are saved in the memory. They are saved in the memory. All right. So to create an array, okay, there is a method called array. A method called array. Right? Guys, can you see, or I have to make it bigger? I have to make it bigger, right? Good? You can see? So we have like a method called array, and we're gonna pass with the object. Okay, on the object. Okay, it could be a list that we are converting it to array, and the data type, okay, by default is none, and copy, true or false. So you're creating a copy of that list or just a view. The order, okay, there is two types of C and F. C means like C programming like, or Fortran like. So usually when the data is sorted in C, they are sorted like rows. So you have like element 1, okay, element 2 for example, 2, element 3, okay. They are saved in the memory like rows. In Fortran, they are done like columns. Alright? And this will make a difference later on. You'll see it when we're trying to search the array to get some data. Alright? So either it's C for C programming or F for Fortran. Alright? That's the order. Okay? And then after that, to lock the information, to lock the array, that means you cannot, by default, you could write to it. So if you make it true, then you cannot change the array. Okay, you cannot change the array. Alright? And then the minimum dimension. What is the minimum dimension? Alright? So again, the object, which is the object exposing the array interface method, then the data type, the copy, the order, the lock, and this specifies the minimum number of dimensions. Let's take an example. Alright? So the first thing always we have to do, import NumPy as NP. From now on we could call any function with NP dot. Right? Right? So if you go in here, for example, to say import the package. Okay. I cannot remember. I have to import the package and import the package. So let's use it here. So the first step we have to do, import NumPy as NP, right? Then, okay, if I need to create an array from a list, okay, so A, which is the name of the array, equals np dot array and I could pass the list I want. So let's say 1, 2, 3. Alright, shift enter, then I have the array created. Alright. Usually if I need to print the array, what should I do? If I need to print any object in Python, what should I do? Print A, right? So that's what it is. The nice thing about IPython, in here you don't have to do print. Okay, just type A, and it will give you it will be quicker, right? So you could do print or just the object and then you execute it. Alright. Alright. So now we have our array ready. Alright. If I need to create two-dimension array, how can I do it? Very simple. So I say md array, and then I'll have the first row and the second row. So in here, what am I creating? Creating 2 by 2 array. So let me take this copy faster to copy it. Copy, and let's put it in here. Control V. Shift enter, print, and alright, so I have 2 by 2 array right now. Good? So that's how you create an array, right? Alright. Then if you move on in here, what I'm doing in here, I'm using one of the options for array, which is nd minimum 2. What does nd min means? The minimum number of dimensions. By default is 0, right? So look at the difference. If I do this now, if I apply this, let me take this out. Okay. Alright. And that means in here I have to have minimum of 2 dimensions. So it will create it in 2 dimensions, although I have 1 dimension. So shift enter. Okay, let me type it in here. So what do you notice? What's the difference between this one, okay, and this one? Okay, here. It will create it in 2 dimension. Alright? In 2 dimension. And you see 2 square brackets in 2 dimension. Alright. Let me remove the 2 dimension and make it, for example, 0. Let's try it, see the difference. So it's created in here in 1 dimension. In 1 dimension. Good so far? Alright. So also you could determine the data type, so it could be complex, could be integer 16, integer 8, it could be any thing, right? So in here, for example, we needed this type, but we said the data type is complex. So when it created it as a complex element. So there is a list 1, 2, 3. Okay, I wish that you have your laptops, you could try it with me. Okay, do you have the link? Do you have the link for this one? Let me put it in the canvas for you. Where's my canvas now? I put it in the announcement, so I think Alright, so if you have your laptop, you know you could try it by yourself. You wouldn't have to. Alright, so what we have learned so far, how to create an array using array function, and there are different options for it. Okay, so you need to play with that little bit and move on. Okay, let's move on here. So there is different data types. So it could be Boolean, like true and false, integer C, which is like integer 32 or 64, integer P, which is like normally it's like 32 or 64, integer 8, which is like a byte, and the ranges from -128 to 127, integer 16, integer 32, 64. Unsigned integer 16-bit, 32, 64, float 16, float 32, and so on and so forth, right? The complex, okay. So these are the data types, the default data types. And you can create your own data types. You can create your own data type, right? Alright, so so in here, for example, okay, if you have an object, if you need to know what is the data type of the object, you could say, for example, use a function data type. You put the array, and you could determine the type of the array. So, for example, in here, okay, data type, that's where you save it. Data type function, and you pass it in the integer 32. Okay, when you print it, it will tell you is integer 32. And this will have direct relationship to the size of the numpy. Remember that in numpy, you are not dealing with the small matrices or vectors usually. It's like sometimes hundreds of thousands of records or millions of records that you're trying to process. So truly, it makes a difference what type you're gonna use. In here, you could create your own data type. So look in here, what you did in here, you created a new data type, and you saved it in DT, and it's an age, and you give it the value of like 8 bits, integer 8 bits. When it's integer 8 bits, what's the range? And signed integer 8 bits from 0 to 127. Right? So in here, for example, after you create this, let's do it. Let's create. And by the way, in here also, the code in here is written in Python 2, but also you could run it by yourself. If you hit in here live demo, okay, you could try it yourself. You don't have to copy there. So in here, when you look in here, okay, execute. So what you have, you imported a numpy. Then you created a new data type. The data type value is age, okay, and it's integer 8. Then you created array, right? You created array, and the array has like 3 elements, and these elements coming from which data type? The data type you have created, the age. It's not a standard one, right? It's a bit small. Alright, so to print it, that is 10, 20, and 30. Alright, you could have a data type that has different, multiple elements. Okay, so it could be age, address, for example, length, whatever ID. It could be like a data type, and each type has multiple elements. Maybe there is an example in here. Yeah. Let's take a look at this example in here. Okay, so in here the data type. All right. So we created a new data type. All right. What's the name of the data type? What's the name of the data type? Student, right? So the D type, it could be built in. It could be built in and made up. Okay. Built in like what? Integer 8 bits, integer 16 bit, float 64 bits, and many, right? Many. Made up like what? Like students. Okay, student in the top, and the student has how many elements inside it? The name, which is string 20, age, which is integer, and marks, which is float 4. Float 4. So whenever you create one element in the matrix, it has 3 elements. All right. So if you are trying, for example, creating a matrix which is like 2 times 2, all right, 2 times 2 like this. That means in here there is a location, in here, location, here, location, here, location. All right. So inside each element, how many information we have? Can you tell me? The name, it has the name, and this is marks, and age. Age, right? Same thing in here, same thing in here, same thing in here. So it could create an array. How many elements it has? 4, which is 2 by 2. And each element, what type? Student. Okay. The student is built of how many parts?
3.
3 parts in this example. Alright? So you could create your own type. You don't have to go with the standard types. Clear? Own types and the So in here, when you say, for example, the data type, what's the name of the data type? Student. All right. So in here, when you print student, and print it, it has a name, string 20, age, integer 1, marks, and float 4. All right. All right, now if I need to create an array of these students, very simple, what I do? NB array, the same thing, right? Right? Then I have a list, okay? A list of what is the size of this array?
2.
1 times 2. 1 row, 2 columns, okay? So this array is like this. This array has like 1 element and 1 element. It's 1 row times 2 columns, right? What is the first element? It has in here A, B, C, 21, which is the age, and 50 is the grade. What is the other element? X, Y, Z. The age is 18, and the grade is 75. You got the point here that you could create your own data types. It could be very complex. Could be your own data type. All right. So when you try to print the array, it gave you the first element in here, and the second element of the array is here. 2 elements. All right. So each built-in data type has a character code that uniquely identifies it. All right. So I, for example, we used in here I1. Where is it? I1. I for integer, right? S for a string, F for a float, right? So B for boolean, I for integer, U for unsigned integer, F for floating point, C complex, M time delta, and capital M for data time, and so on and so forth. So far we learned how to create array, right? And we learned how to create types, and then we learned how to create an array with your own type, with your own data type. Alright? So in here, don't forget that when you have your own data type, you have to specify in here what is the type you use. So we have created student as a type, and we specify when we create the array that this data type is used, the one I have created. Okay? Alright, so we come now to array attributes. Alright. So, what are the attributes usually we would like to know about any array?
Size.
Shape, size, right? Okay, so in here, for example, I have this array, which is like how many rows? How many rows is this array? I feel that a lot of you are sleeping. Okay, people in the back there, I need you to come here. Please. Alright? All the four there, come in here. Alright? Alright? And the question to you, to wake you up, don't. Alright? Alright? Alright. How many rows we have in this array? Two. How many columns we have? Question for him. How many columns we have? Thank you. Good man. Alright? So we have one row, a second row, and we have 3 columns. So if we would like to know the shape, remember this is a very easy by visually you could get the shape, right? But if you have a data set that you are importing, your NumPy, which is like 200 by 555. I'm sure that you cannot read it by your eye. So you use the attributes. So what you do in here, A, shape, it gave you, it's like 2 by times 3. Alright? Alright? Guys, I told you here, 4. I reserved this for you, here. Okay? Because I need to ask people. Too far, I cannot ask you. Okay, come on. I assume that you are following me with, you're doing it by yourself, right? Thank you so much. So be ready for 4 questions. Okay. Which one would like to have the first question? Any volunteer? Would like to have the first question? Okay. When it comes. Okay. Again, as I told you, I feel obligation inside me to make sure you are part of the class. And I know you are here because you want to learn, right? Otherwise, why you will come? There's a video. You could watch the video, right? So it's you'll get to your question. Don't worry. All right. So in here we have another one in here, array, and then what we did in here, we said a dot shape 3 2. What we did in here, we changed the shape. So it was 2 times 3, and then in here we changed it to be 3 times 2. So you could play with that. So now this array has 3 rows and 2 columns. Alright? Moving down in here, okay, you could use a function called reshape. You could reshape any array the way you want. So in here we have, this is like 2 times 3, we reshaped it to 3 times 2. Reshape, which does resizing for the array. All right. In here, for example, in here we could use arrange. All right, arrange like range. Remember we learned about the range when we say range 24. How many elements we're gonna have? 24. 24, right? Yeah. Starting from
0 to
23. 0 to 23. So that's the easiest way to create an array. When you print it, it will tell you from 0 to 23. All right. Same thing in here. So what we did in here, the number of dimensions. In here, we're trying to know what is the number of dimensions. Of course, if we are using like your IDE, what you should do in here, print a dot in the, okay, but in here because anyways, so the dimension. So what would be the dimension for this? How many dimensions we have for the A range in here? One. Let's try it. Live demo. Okay. I'm very sorry. There is a lot of advertisement there. I don't know how to block it, but if it bothers you, I don't know how to block it. So, all right. So we imported the numpy, and then what we said in here, we created a range. All right. Okay. And in here, what we did reshape it. Reshape it to make it like 2 times 4 times 3. So what is 4? Number of rows. What is 3? And 2 is number of sets. You could think about it there like third dimension. So as you see in here, this is like the number of rows is 4. And number of columns is 3. And we have 2 sets. So what is the dimension of this one? 3. It's like 3. A, B, C, X, Y, Z. 3 dimensions. Alright? When you printed that. Okay? So it's a very easy to use reshape to change okay, so 24. So you could also, for example, so you could say, for example, 2 times 2. How is that? How many dimensions we have in here? 4. 4 dimensions. 2 times 2. 2 times 2, 4. Times 2. 8 times 3, 24. That's what we need. Let's try it. Alright, so this is a 4 dimensions. So that's the beauty about NumPy. You could have endless number of dimensions. Endless number of dimensions, right? So in here you have, so again, in here, what is the 3 in here? Number of columns. What is 2? Number of rows. Okay, and this is the first set. Okay, each set has two sets, and the 2 in here is the 2 sets, 1 set and 1 set in here. All right. Okay, so can you make it like more out of 24? Can you make more than 4 dimension? Can you?
Oh wait, no. Can do 6.
How about if we try this? Try 1, put 1 in here. What will happen?
I'm just making the whole thing. Let's just make it one set of 2 sets of 2 sets of.
So it added like another here, see, to make it like 5 dimension, but did not change it because it's still 1. So the whole thing, it's 1, right? If I add one more 1, just watch it. See, added 1, so it's like 1 set inside 1 set.
What if you change them from a different item?
Yeah, what if it's a 2?
We can, what is if 2?
Yeah.
We cannot, because you don't have enough elements. So if, you have 24 elements, right? So how can you make it like, if you change 2 in here, for example? So how many elements we have now? 24 times 2, 4, right?
I see.
Okay, but this will try it.
Yeah.
Okay.
Oh, I see.
Okay, so you have more elements, right? Okay. By the way, this tutorial is very long. To be honest with you, myself, I was planning to cover from that textbook. You could cover it from anywhere. So I decided to play with this morning. So I think I spent like 6 hours until I finished the whole tutorial. Myself. Okay? course, it included coffee, tea, breakfast, few calls, and all of that. You get bored a lot and all of that. So I'll try this week to give you a smaller homework because you have to go over this. And I know, I mean, Python usually you should cover it like 3-4 lectures. We're gonna cover it in one lecture. We're gonna keep it for you to go over, right? But seriously, how much you can do in the class? I wish you brought your laptop. The best thing is to try it yourself. That's the way you do it, right? So I'm gonna go over key points, but not all the points, okay? And and I'll give you a small homework. My homeworks are all small. I'll give you a homework and that you play with it. That after you try it, I need you just to believe me. I don't try to torture you or ruin your life. But that's the only way to learn programming is to, you don't need even to be smart to learn programming. Like if it's physics or chemistry, if you are like super smart, you'll pick it very fast. And here it just comes by experience, or by mistakes. How you learn by mistakes. You do mistakes, you learn from it. All right. The smart part that instead of spending 1 hour to fix a problem, you spend 30 minutes. But still, you have to have the problem and the typo and the problem in your code and of course, you have to have your own logic. So, all right. So you got the point, right, in here. Then you have the item size. Like usually the array built of items, all right? So you would like always to know the item size. So there's a function for you called item size in here. So you have this array. So this array, for example, is built of how many elements? Quickly, how many elements there? 5. And we determine here what is the type. What is the type in here? Integer 8. All right. So what is the item size? 8 bits. That means it's 1 byte. It's 1 byte. Okay. So let's go play with the demo here. Okay. So let's say I want it to be 16. So each item is represented by 16. So how many each item will be?
2 bytes.
2 bytes. If I make it like 64.
4 bytes.
8 bytes, right? All right. How about if I make it float? I'm not sure how you write float. Is it F or what? Float? F? Let's try it. I'm not sure. Float. Right? This is like float, right? So, is it important? Is it important that an item type? Yes, for 2 reasons. What's the first reason? That's your question.
You want to connect it to the maximum if there are like too many.
Take your time. I have nothing to do.
The sizing is
So, for example, if the range of the elements is only up to 28, do you need to have integer 64? You don't. You're using a lot of memory for nothing, right? Right? Because like if you have like 16 bits, you could range from, or 8 bits from minus 128 to plus 128. So you don't have to have that much of a size. Plus, again and again, we use this for machine learning, data learning, deep learning. Usually you build arrays like it has like million dimension by 1 million, right? Or 1,000 by 1,000. All right. So processing this data, when you start, it's not like now you're gonna start execute. It's gonna give you the answer in 2 seconds. When you do machine learning, deep learning with with all the data, you hit execute. You're gonna have at least like 20 lunches and dinners before you have the answer. All right, so and you have to have a good computer with a good memory, with good space, and all of that. So this is part of the design. You have to know what you need, right? All right. So you have to know what. Before when we used to teach programming a long time ago, we never worried about these things because whatever you do, small programs, okay. this course is leading to machine learning and deep learning, where you deal with a huge amount of data. All right. So the way you define, what if you are reading data, and which is like big. I mean, like the numbers are huge, but you made it only integer 16. Does not fit. What will happen? You lose data. You lose data, right? Okay, lose data. So it's like for example, you are reading. I mean, like you're reading it. Say that you're reading a number, that number 7, 1, 2, 3, 4, right? And you just allocated 3 places. So 4, 3, 2. What happened with these numbers? Gone. Okay, you didn't have the right data. So you have to study your data before you importing it or designing your number. You have to know what kind of data you are getting to your arrays and your matrix and what are. If you make it huge, it will be a problem. You're reserving a lot of the memory, okay? And if you make it too small, you a lot of the memory. All right. So everything has a reason. Everything has a reason. I hope you got this point. All right. So we'll go in here. So okay. All right. This is another example in here. This is float 32. Right? It will give you 4 bytes. Okay, and there is a attribute called the flags. The flag will tell you some characteristics about your array. So, for example, will tell you if it's contiguous, C style, or it's Fortran style. And I already explained what's the difference. So, C style stores the data, okay, horizontally, right, like a row. Fortran style like a column, all right. And this will make a big difference later when we start reading and slicing from the slicer. So in here, on data, the array owns the memory it uses or borrows it from another object. All right. Myself, to be honest with you, I don't know what does it mean in here. Okay, but since it has anything to do with the memory, this is very important. Very important. Okay, the data area can be written to setting this to false, locks the data, make it read only. So you could make your array read only. Okay, and maybe that's wise when you have like some arrays that while you're running the program, you want to make sure you don't change it by mistake. So you could make it writable or read only. Okay, align the data and all elements are aligned appropriately for the hardware. Also, this is hosting is very advanced. I really don't know what does it mean. Okay, and so on and so forth. So these are the flags. So if you would like to know the flags of you created in here, for example, an array which has like 5 elements, you could print the flags and tells you this is like C contiguous, F contiguous, etc., etc. Okay, information about it. Let's go to the next session. All right. All right. Now this section will tell you how to create different arrays. All right. Sometimes you need to create like quickly we'll go over it. We'll have a break. So you would like to create like different. So empty. All right. Empty. It will create an array. And here you could tell what the shape is. Is it 2 by 3, 2 by 3 by 4? What is the shape? And the data type again is float, for example. By default is a float. By default, if you didn't put this type, it will be float, but you could change it. And the order by default is C, but you could change it to F. All right. So let's take a look example right away. So in here, I'm creating an empty. So what is the shape? 3 by 2. That means 3 rows and how many columns? 2. All right. And what is the data type? Integer. Okay, so that's what it is. It created for you. Okay, it's an empty. Empty, that means it's random. It will check. It will pick like a random number. Random number. Okay, so that empty means you did not determine what word. Okay, you could create a zeros. So instead of the word empty in here, what are you gonna use? Zeros. So you're gonna tell the shape again, the data type, and the order. So let's take a look in here. All right. So in here, what I'm doing? Zeros and 5. zeros, okay, 5. So I'm creating an array. What is the size of the array? Okay, it has 5 elements, 1 times 5, and all zeros. So what is the data type in here? Float. Why? Because by default is what? Float. Alright? You could change it to whatever you want. Alright. Then after that you could use, and here in zeros, for example, zeros, we're creating, what is the shape? 2 times 2. And what is the data type in here? You're creating your own data type. So the data type has how many elements? 2. The first element we call it x, and it's integer, 4 bytes. And the second one is called y, and integer. It's like a point, for example. So as you see, you created 2 by 2 matrix, and it's zeros. So 0.00, 0.00, 0.00, 0.00, right? Alright. Alright. Can you create ones? A matrix with ones? Yes, it's given for you. Okay, ones. Alright? And again, the same thing. If you say ones 5, it will create a matrix which has 5 ones. If you say, for example, 2 by 2 with ones, it will create a shape for you which is 2 by 2, and all the elements are ones. Alright? There are so many functions, and by the way, this tutorial covers maybe like 50 or 60% of the functions that you could use. Is so powerful, okay? And sometimes when I was looking at some of the functions, really did not make any sense for me. Why would they have it there? What again? I'll show you some examples, okay? But it's so deep, all right? So usually, like, let's say that you have a project and you're gonna use NumPy or pandas. What is the most wise thing you need to do? You would like to know what this package avails to you, what gives you, okay? Because sometimes you need some function and you spend like writing the code, a lot of code, but it's there. It's there for you, right? It's already there. So spend, like, let's say that you have a project that you're gonna spend a month, and you have decided to use NumPy for it, right? If I were you, I spend like 2-3 days and go at every single function, just peek inside, peek. What does it do? Maybe it will be useful, okay? If you would like to know all the functions, what is the simplest way to do it? Go to a bicharm, NumPy dot. What does it do? Display all the list for you. That's what I did today. I looked through them. So it will give you attributes and give you functions that you need. Just take a look at them, play with them. You know, you could that's what it is. All right. So let's have a break. For 5-10 minutes, and we'll come back. All right. So we could create arrays from existing data using a method called asArray, and you're gonna pass the existing data for it. Could be a list, for example, the data type and the order. Again, I already explained this a few times. What is the order? What is the data type? So, for example, what is this? A list, right?
Yep.
List which has 3 elements, right? So I could create an array from a list. So any list, I could convert it to array, NumPy array. Okay, so as array, okay, and then you pass the x, which is a list, and now I have it as an array. And by the way, I mean when we go to the Panda, you'll find that usually we start with creating an array or matrix using NumPy, and then we convert it to something called data frame or data frame. So Python, we have like array or matrix in NumPy. We have something called data frame in Pandas. All right, Pandas is built on top of NumPy. It's built on top of it, and Panda is like so huge. You could do so many things with it. As we'll start, we're gonna have 4 lectures talking about Pandas starting from next week, right? So just I wanted you to know. So if we jump directly to Pandas, you don't really know too much about NumPy, but it's good to know it. It's good to know it, and maybe like for many people, they hear about NumPy more Okay, especially those to use like mathematical equations, solutions, yes.
With NumPy in pandas, would they be, it's a combination of both, but they can be used as MATLAB, like a similar use?
Yeah,
Because just
yeah.
one licensing between MATLAB is extremely expensive. Looking for a product.
Well, pandas is mostly used for like creating data frames and used for machine learning and deep learning. Okay, so what is data frame? Is like a matrix, all right, but has like the data could be different types. Okay, in NumPy, all the elements have to be the same type. All right. Pandas is faster. It's built on top of NumPy, and has so many functions with it as we're gonna see. All right, so it's kind of, but if you planning to create like matrices, matrices to solve equations, NumPy to go. There's a third package that those things, these three packages like triangle work together. NumPy, SciPy, which is the scientific package, with the pandas. All right. I wanted myself to cover. By the way, you could put some material for you about like SciPy if you're interested. But I would like really to go like in data science, machine learning as much as we can. All right. Unfortunately, we cannot cover everything. There's each package, so I'll try to give you like introduction as much as we can. But really, I have to depend on you to learn. I mean, you have to even like NumPy. Today is just kind of introduction, but you'll have a lot of work to learn by yourself. All right. So in here, for example, I have a matrix. I have created an X, and then in here, what's the input? What's the typing here? It's like integer. I want to change it to float. Easy. Just determine what's the data type that you want to do. Float. It could be complex. It could be anything you want, right? So now I have an array, and the elements are float. The elements are float. And here, okay, this is the other iterable. What is this in here? What is X in here? Tuple, right? It's not a matrix, tuple. And again, I read it to the array, and I created array of a tuple, which is a tuple of integers. All right. How about in here? What do I have? I have a list of tuples. Okay, tuples. List of tuples, tuples. I don't know how people pronounce it. I checked Google. Some people say tuple, some people say tuple. Both are good for me. Alright? Alright? So this is a list of two tuples. Alright? And then when I imported it now it will give you array of two tuples. Okay? Two tuples. Also in here, for example, there is another function called from buffer. So this function interprets a buffer as one-dimensional array, as object that exposes the buffer interface is used to as parameter to return. Okay, so in here we have the buffer, we have the type, we have the count -1, could be -1, could be positive, and the offset. Now let's take a look a little bit. The buffer is an object that exposes buffer interface. That means you're reading directly from the memory. Let's take example in a second. Data type, like we learned before. Okay, by default it's a float, could be anything. And the count, the number of items to read. Default is -1, means all the items. Remember, like in the list, when you say 0 to -1, that means all, right? So -1 means all the data read from the buffer. Offset where you start. You start from item 0, by default is by 0. Start from 0 to -1. -1 means all the data. Or it could be offset with a maximum data to read. So in here, for example, I have S, which is like a buffer or a string of data, hello world, okay? And I'm trying now to read it to where? To an array. So I'm reading it from array and creating array with A. I call it A from the string. And what is the data type in this buffer? Is a string. So now I have an array of integers. Alright, you could read it from iterator. Alright, what is iterator? is an object. Remember, everything in Python is an object. Iterator. So you could have iterator for list. You can have iterator for tuples, right? Iterator for dictionaries, right? What iterator? Remember, we created iterators before, right? In the advanced, what is iterator?
Implements the iter function.
Iterate function that you could
Call the
iterate
next
through
one.
the iteratable object. All right? Using what? Next, start, and next, right? So you could create yourself what? You could create your own class, which is objects, okay? And you could create your iterable in that class, right? Okay? Or for already existing like iterables, they have, or objects, they have their iterable. So can we create it from iterable? Yes, we can. All right? So from iterable, this is the iterable. Okay, could be a list, could be a tuple, could be then, you know, the type and count -1, that means all. All right, so let's take example. So for example, in here, a range. So range will create a list. Okay, a list equals a range. Okay, when you print it, okay, range 5. We learned that a long time ago. We'll give you a list from 0 to 4, 5 elements. And is it integer or float? Integer. How about a range? What is the default? Float. For a range, the default is float, right? Which is part of NB, NumPy, right? So I created a range, all right? And then what I say, I created iterable object. There's a method called iter. What does it do? Will it create an iterable object out of this list, all right? So if I do print type it, what will give you? It's an iterable, right? Okay, iterable. So in here, what I'm doing in here, from iterable it, which I created, create what? Create an array. What's the name of the array? X. If I print the X, will be, okay, so you could create array from any object, from the object of list, tuple, string, which we call buffer, or you could create it from iterable. Okay, iterable object or iter object. Create an object. All right. Somebody will say, I mean, that's a question I asked myself, why I needed to go through this. I mean, what I did, I have a list, right? I could create it directly from the list object, right? I didn't have to go. So, I mean, they give you a lot of options. I'm not sure what the scenario that I will need to use this, but I'm sure there is. I mean, seriously, they give you so many functions, so many things that you could do. Array from numerical ranges in here. So we learned about a range. So a range is like range. It has a start, stop, step, and the data type. So let's take example. All right. So let's take a demo also. No problem. All right. So in here, I'm creating an array. Okay, I'm creating a range 5. So 5, what does it mean? How many elements are we gonna have? 5 from 0 to 4, right? From 0 to 4. Let me execute it in here. Okay, 0 to 4. If I say like 0, okay, to 5, and this will give you an error. Why? Because you're supposed to have it like comma, like this. All right? Right? 0 to 5. If I have the step is 2, as we learned before, okay. Now I could add what else I could add? Data type equals float, for example. Execute. Now it's a float, right? In the range I don't have the data type, right? A range I have the data type. Look at second example in here. A range 5. We already done that. Okay. In here, starting, ending, and the step. Okay. All right. This is very interesting. I like this function. Okay. Line space. Line space is a very interesting one, which is like you have the start, you have the stop, and how many elements between the start and the stop you need, all right? And then you have the endpoint, the start point, and the data type. So let's take example. Maybe you have example in here. Okay, live example. So in here, all right. So and here I'm doing line space from 10. So what is the first element? 10. How many elements are gonna have?
10.
5. Between 10 and the 20, not inclusive. That makes it easier. So it's kind of slice it equally. Slice it equally for you. All right. So it starts from 10, then the 12.5, 15, 17.5, and the 20. So how many total elements we have? 5. And we'll slice it for you equally. So the distance between each element and the element, okay. So if I change it in here, for example, up to 40, for example, and we execute it, all right? So 10, 17.5, 25, and if I make it this, for example, 10, it will slice it here equally. So it will guarantee that you're gonna have equal segments, okay, and in the range, clear? So it's a very nice, so endpoint equals false. What does mean endpoint equals false? That means the end here does not include, so the endpoint equals false by default, hence the stop value is included in the sequence. If false, it is not included in the sequence. So in here, the stop point was what? 40, right? It was included, okay? If I change it in here, for example, and it has to be capital, but it has to be capital, so it's always capital actually, in Python. Okay, no. So you see the endpoint was 40, was not included. It was not included, but still we have like 10 points spaced, 10 points spaced. Clear? Okay, and so on and so forth. Then also log space. What is log space? It will be like logarithmic, spaced out. So for example, in here, by default is base 10, but you always could change to base 2, or base whatever you want, base 2. So in here, from 1 to 2, 1 to 2, and base 2. So it starts from, you need to have how many, 1 to 2, and the number is like 10 points. The number is like 10 points. And here the number 10 points, but you change the base to the base, so on, so on, so forth. So it's like a very nice function. Okay, indexing and slicing is exactly like before, except now we are dealing with multiple or multi-dimension, n dimension, right? So you have to be very careful about that. Let's create a range 10, so how many elements we're gonna have? 10, all right? And here what we said is slice it 2, 7, and 2. 2, 7, and 2. What is slice 2, 7, and 2? So you created a slice, okay? When you print it is 2, 7, and 2. So what do you have sliced? Starting from 2 up to 7, and the step how much? 2. So 2, 4, 6, that's it, right? And that's what we have, 2, 4, 6, right? Also, you could have the slicing the old way we have learned. Remember this way? Okay, 2, 7, and 2 with columns. The same thing will give you the same results. So you could use a method or a function called slice, or you could use the indexing like we did before, or you could mix them together. All right. So in here, for example, in here we create an array of 10 elements from 0 to 9. So in here, what I'm doing in here, A5. What should be the result? The element of 5, the index by 5, right? Which will be 5 because we have 0, 1, 2, 3, 4, 5, right? How about in here when you say 2 colon 2, what does it mean?
Starting from second and
Then it's arranged from 2, what is the step? 1, and until the end, right? Until the end, so 2 until the end. Alright, how about in here? Start from 2 until 5 and the step is 1. Exactly like we did before. Now it becomes a little bit more complex when we have multiple dimension. So we have to have indexing for the rows and indexing for the columns, okay? Like we did before. So in here, for example, okay, this array, how many rows it has? 3 rows. How many columns? 3. So let's take a look in here. All right. So what I'm doing in here when let me execute it first. All right. So when I print the array, it was 3 by 3, right? And when I'm doing indexing, the first part of indexing in here, what I'm trying to do is the first thing will be for what? It should be 1 for the rows and 1 for the columns. I did not talk about the columns in here. What I spoke about? The rows. So what I said, I need row 1 to the end. So how many rows I have? 3. 0, 1, 2. So how many rows I can extract in here? 1 and 2. And since I did not talk about the columns at all, how many columns? All the columns. So that's what we did. Where's the rows? Okay, 1 and 2. And all the columns, that's what I have. Rows 1 and 2 and all the columns. All right? In here, for example, okay, in here, how many rows I have? 3. How many columns? 3. All right? So in here, what I said for the rows, in here, when I put 3 dots, what does it mean?
Keep 3.
All of them, right? And then I have 1 column. So it will be the column in the middle, number 1. Okay? So when I do that, let me run it. Alright, let me execute it. Alright, so in here A was printed in here. 3 rows and 3 columns. Right? Was printed. Then what I did in here, I said I need to print A, okay, this items in the second column. The items in the second column are, so in here the rows, I'm printing all the rows. Don't talk about the rows, and only the second column. So what are the items in the second column? 2 and 4 and 5. That's what was printed. 2 and 4 and 5. Look in here what I did. And here I said, okay, let me worry about row 1, row indexed 1. That means the second row. And I need to print all the columns. So where is row 1? This one, and all the column, which is 3, 4, 5. 3, 4, 5. Okay, so you know it's you could index as you want. So we have also, this was the basic indexing. We could have advanced indexing. Okay, so let's take a look in here. You have in here an array which has 3 rows and 2 columns, right? And in here what they have, x, okay, x equals, yeah, like, so, so it will take, okay, y will take row 1, row 0 and column 0. So it will take 0, 0, which is 0, 0, which is what? The 1, right? And then also takes 1 and 1. Where is 1 and 1? 1. This is like 1 and 1, which is here, right? So this is 1 and 1, 1 and 2, no, 0 and 1, 0 and 2. This is 1 and 0, 1 and 0. Okay, this is 1 and 1, 4. All right, and then it says 2 and 0. So that means 2 means second row, which is supposed to be here, and column 0, which is 5. So let me do it in the board. So before I do this, why do we need advanced indexing? Because in the regular indexing, what we are indexing, we pick up like a range, right? But we cannot pinpoint a single element, right? Right? We cannot. In the advanced indexing, we could pick like a single element. So, for example, in here, what is would be more clear to see it this way. And, come on. So in here, okay, we created like a matrix, which is how many rows? 3. 1, 2, 2, 3, 4, 5, 6. This is a matrix, right? All right. So here is the row 0, row 1, row 2, column 0, 1, right? So we create. I mean, if I need to pinpoint certain elements, not with the ranges, I could use the advanced. So in here, okay, x, which equals, okay, this is the row, and this is 0, 0. Where is 0, 0? This is the 0, 0. Right? 0, 0, which is 1. Okay? And then I need to pinpoint 1 and 1. Where is 1 and 1? 1 and 1 here. What's the value? So 1 and 4. So we pick this and pick this. Then the third one is 2 and 0. Where's 2 and 0? 2 and 0. This one, 5. Right? So the output is be 1, 4, and 5. And that's what we got in here. 1, 4, and 5. Right? So with advanced indexing, you could pinpoint the elements that you need to do using X and Y. Okay? So in here, another example. Let's take another example in here. And let's execute it. So in here we have the array X, how many columns it has, how many rows it has, 4, how many columns, 3. So I created in here, okay, the NB array, so this is the rows, 0, 0, 3, 3, and the columns. So now I'm creating a submatrix from this, but what I'm picking in here, 0, 0, 0, 2, that's the first row. Then I have 3, 0, 3, 3. Okay, and that's what. So let's get it right. So 0, 0. Where is 0, 0? There's 0. Then after that, what? I have 0, 2. Where is 0, 2? 0, 2, which is
2.
Which is here. Then what I have 3, 0. 3, 3 here, and 0 and 9 in here. And then I have 3, 2. 3, 3, and 2, which is the 11 in the Alright? So it's like really advanced that you could pinpoint, you know, to the element that you would like. You could mix, by the way, in here, for example, indexing, like in here using the index, and you could mix them. So in here is like the range, and you could have the elements. You could also, like for example, by having the Boolean array indexing, So for example, this is the array in here, and you would like to print any element that is greater than 5. So it will look at all the array and print all the elements that are greater than 5. So you could apply any, logic there you would like. All right. Right. Okay, the most important thing about NumPy is the broadcasting. So for example, you have in here an array which has 4 elements. Array in here you have 4 elements. When I say A multiplied by B, it will broadcast. You don't have to create a loop to do that. So when you multiply array A with B, it will go multiply 1 times 10, 2 times 20, 3 times 40, 4 times 3 times 20, and 3 times 30, and 4 times 40. So it will broadcast, and you will see the output will be automatically broadcasted for you. Same thing with addition, subtraction, whatever you do. In here, for example, the best thing for broadcasting that both arrays have to have the same size, right? But what if they don't? Can we still broadcast? Yes, we can. So look in here. At least we have to have 1 equal dimension. Then we could broadcast. So for example, the A array in here, what is how many rows and how many columns? 4 rows and how many columns? 3. How about the array B? 1 row and 3 columns. Can we broadcast? Yes, because at least 1 dimension are equal. So when I do A plus B, what will happen? Okay, so this one will be added to each row. Will be added to here, will be added to here, will be added to here, and will be added to here. Alright? So it will be broadcasted, and that's exactly what happened. So it was added to the first one, the second one, third one, and fourth one. So that's what happened. So we have in here 4 times 3 A array, and this is only 1 times 3. So basically it will be filled in here, and that's what we do. If we're gonna add, we're gonna add 0, 1, 2 to this, 0, 1, 2 to this, 0, 1, 2 to this, and so on. So that's what is broadcasted. Alright?
Basically, leaving algebra.
Hmm?
Leaving algebra, basically.
Well, yeah. So iterating over array, can you iterate over array? Yes. So in here we created a range. So how many elements we have in here? From 0 to 60. Okay, and the step is 5. So we'll reshape it to 3 by 4. 3 by 4 matrix, right? Could I iterate inside it? Yes. So for x, n, and p, the n the iter of a. So the iterator of a, and then print x, and you could iterate with it as much as you want. Okay, you could, there's further things you could do with iteration. Okay, you could take a look at it yourself. You don't have time. So array manipulation. All right. So you could have reshape. We already took a look at this. You could reshape it. Okay. You could flat it, make it one flat. So it's like 4 by 4. You make one flat. It will be like one array. Okay. Okay. You could use flatten. Return a copy of the array collapse into one dimension, and ravel, which is like let's take one at least one. Okay. In terms of transpose, you know what's transpose, right? So when you have an array, you could transpose it. So there is transpose, or there is t as an attribute. You could do that. So let's take a look at one of them, transpose only. All right. So you have in here an array which is like 3 times 4, right? Let's execute it. So this is like 3 lines times 4 columns, right? When you do transpose, what will happen? The rows becomes columns. So 0, 1, 2, 0, 1, 2 in here, and so on and so forth. So there is a function for transpose. Basically, all the operations that you used to do with matrices in your math class, you could do it in here in one click by calling a function. The identity, the transpose, the determinant calculation, all of these things that you used to do, you could do it in one click. In one click. So you have different. So broadcast, mathematical functions. So you could concatenate. You could calculate matrices together. You could stack them together. Let's take one example only. Let's take stack. Okay, let's take this stack. There's a lot of functions that you need to play with. So in here, what I have A, which is like 2 times 2, right? And have B, which is 2 times 2. When I stack them together, I have only to say stack A and B, stack A and B, all right? And it will. So this is the first one. This is the second one. When I stack them together, what will happen? They stack on top of each other. When I say concatenate, will be next to each other. All right. So there is a different algorithm, different methods available for you to do. Like you have stack, horizontal stack, vertical stack. You could split the arrays. So split, horizontal split, vertical split. Also, you could add, remove elements, you could resize, you could append, you could insert, you could delete, you could unique values, pick the unique values. All of these are methods available for you. Play with them, please. Alright? Then we come in here to binary operators. You know what's binary operators? Like and, so you could have the bitwise and, or invert, left shift, right shift, All of them are functions that are available for you. You could work with them. You have string functions. You have string functions. You could add, you could multiply. So what is add? You could add a string to a string. You could multiply a string. Let's take one. Let's take an example. So for example, you have in here a numpy that call that multiply hello 3 times. So you're gonna repeat it how many? 3 times. So there's few methods just to deal with strings: lower, split, strip, join, replace, decode, code. All of these are functions are available that you could use. All right. Then we have mathematical functions. Like what? Okay, sine, cosine, like trigonometric functions, sine, cosine, all available for you. Okay, so you have a range here of degrees: 30 degree, 45 degree, 60 degree, 90 degree, right? So in here, what you do, you try to, but what we have to pass to the sine, we don't pass the degrees. What we pass? Radian. So we have to convert it to radian, right? Simple math, right? Radian. We convert it to radian, right? So you have the degree multiplied by pi divided by 180. That will give you the radian. All right. You could convert it back from radian to degree. Okay. And you could inverse sine. You could have the inverse sine. So many functions, all the mathematical functions are available for you. All right. So you don't have to worry about it. That's why it's like in the math package. You could do many things. Arithmetic operations. What are the arithmetic operations? Okay. So you could have, for example, in here, you could have the multiply. Okay, you could have divide, addition, subtraction, all of them. So you could add a matrix, multiply matrix. You could have reciprocal. You know what's reciprocal, right? Okay. You have the power function. And you have the mod operation, modulo, right? Calculate the modulo. And you have the remainder, which is like a modulo. It's the same thing. So many mathematical functions are given to you. All right, you could use it. All right, statistical package. Okay, you could calculate, for example, the mean, the average, the weighted average, the mod, the standard deviation, the variance. All this is statistical. All right. All you have to use a function. All you have to use a function. And as I said in here, does not matter the size of the array or the matrix. It could be like 1,000 by 1,000. I mean, if somebody asks you to calculate, for example, the average or the median, okay, the median for, I mean, if you have a matrix which is like 10,000 by 10,000. Okay, so you need to calculate the median for the whole matrix, a function. If you need to calculate the average for a certain row or certain column, it's a function. It's all given for you, just you have to know how to use it, right? It's so powerful tool. It's like MATLAB. We use this in MATLAB a lot, so it's all like, MATLAB, you have to use it like in MATLAB, right? The only difference now, you are doing like programming. Then after that, when you have data like this, concatenated data together, what is the main thing that always you would like to do? Sorting, right? Sorting, right? Maybe in your programming language, you wrote sorting programs, right? It's available for you. So there's many functions in here for sorting that you could use, okay? So you have a quick sort, merge sort, and heap sort. All right. Sort in here. You could, for example, I need to sort the array A in the axis, whatever the axis, and the kind. You determine what is the kind, one of these kinds, and the order, and we'll give you the result. Okay. So for example, in here, for example, sort A, it will sort it for you in a different kinds of sorting. All right. So you don't have to go. Okay, so let's say, for example, that you have a program. Forget about NumPy right now. You have a program, your program, right? A Python program, application. All right, and just one of the things that you need to do is to sort the data. All right. So what is the easiest way to do it? Save the data in array, okay, and sorted using NumPy. So very strong and very fast. It's a very fast, that's the key, right? If you write your own code for sorting, it will not be because all the operations done through the memory, swapping inside the memory. Right? So you have a sorting application, whatever, Python, whatever it is, right? Okay, you have like a web page that, you know, that calls the numbers for the ages. For let's say, for the 5,000 students we have in UB. We'd like to know so we have 5,000 age numbers, right? You need to sort them, for example, or you need to calculate the median, you need to do whatever, okay? So the best thing is to save them where in array. Call it, save it in array, call these functions, okay? And these functions, the main advantage, they are so fast. They are written optimized. They are written optimized, you could use them, right? So whenever you need to, you could do that. Right? Alright, this is all the sorting thing in here, extract, so whatever. Okay. Then what we have, byte swapping. This byte swapping is, you know, I'm not sure what is it useful for, to be honest with you. I went through it, but it's basically, you know, how to swap the data in the memory from hexadecimal to binary, so I'm sure there's certain applications, but I'm not aware of it. And there is a very important topic, which is copies and views. So usually when you create like an array from array, is it a view or is it a copy? All right? By default it's a view, so it's the same memory, right? But if you really wanted to have another copy, that means, and by the way, this is very dangerous. Remember that again, when you're working with NumPy, you're not working with a small matrix. You're working with a matrix like million by million, right? So if you are trying to create another copy, you have to make sure you have enough RAM and enough, in your machine, right? So are you creating a copy or a view? So basically, if you have to create a copy, there is a function called a copy. So you cannot say A equals B, because this will be and we learned that, by the way, with lists, if you remember, right? So if I need to create a real copy of the data, what I have to use, I don't have to use shallow copy or view. I have to use the real copy. Where is it? Somewhere here. And here, deep copy. We spoke about this when we spoke about lists, if you remember, right? Shallow copy and deep copy, right? So there is a function called a.copy. So in here, what I'm doing in here, I'm creating a deep copy. That means I'm allocating memory in the RAM for that new object. It's not a view, all right? So you have to know what you are doing. You have to know what you are doing. You'd like to create a view or a real copy. So that's one thing we should be aware of. All right. So we spoke about arrays, which could be, there is some subcategory called matrix. Okay, matrix, how many dimension is it? 2. When you say matrix, is a 2. So you could create it with matrix lib, okay? So if you like to create an empty matrix, matlib empty, all right? So let's take example in here. So you'll say matrix empty 2 by 2 will create 2. So there is like subcategory. In the array, it could be 2 dimensions, could be 1 dimension, could be 3 dimensions, could be 4 dimensions, could be 100 dimension. Okay, imagine. You cannot even visualize it. In my brain, I could visualize 2-dimension array. That's good. I could visualize like 3-dimension array, right? Right? But when it comes to 4 dimension, it's very hard. And the graphs usually, how many dimensions? Nowadays, 3. Any different opinion? The graphs, how many dimensions? In your opinion? Just be honest.
I think it's 3.
3? How about you? Two. The graph's two. You don't see 3D?
Oh, no,
3? Okay, about here?
Three.
3.
I was gonna say 2 and 2.
Many.
Graph many? How many? Yeah, give a number.
Each graph, it depends on application. I think we just need most common.
For example, like let's tell you like building a block 3D printer. How many dimensions? 3? Not you.
4.
4. Who said 4? What's the fourth dimension?
Time.
Time.
It's the
Okay.
of the internet.
So now we have 4 dimension. Okay, everything. We have 3D, but we have the 4th dimension, which is time. Alright? Okay? So how about 5th dimension, 6th dimension, 4th dimension? Alright? So it's really gets, much more, anyways, so there is many functions for matrices. Then it comes to linear algebra. So what's linear algebra? You have the multiple equations that you try to solve them. Okay, like so there is you have dot multiplication for matrices, the vertical dot, inner multiplication. Determine, solve. So for example, let's take a look at solve. So you have the set of equations like that. Set of equations like that. How do you solve them? So you take the parameters 1, 2, 2, and you create a matrix, and you try to do the solution, right? So it will solve it for you. If you would like to calculate, for example, the inverse of a matrix, it's just one function. So you have in here this matrix, and if you'd like to get the inverse, you just call the inverse and pass the matrix, and it will give you the results. That's the inverse. Alright? If you multiply the matrix with its inverse, will give you what? Give you what? Matrix with its inverse will give you what? $5, right? Give you the identity matrix, right? When you multiply a number with its inverse will give you what? 1, right? Okay. When you subtract the number from its inverse will give you the identity. What's the identity for subtraction or for addition? 0. 0, right? What's the inverse of 5? What is the additive inverse of 5? Minus 5. 5 minus 5 will give you
0.
0, right? So anything operation with its inverse will give you the identity, not the 0, give you the identity. So multiplication identity is 1, right? And and in here, so what is the identity matrix? For example, 2 by 2 identity matrix.
1, 0,
1, 0, 0, 1. This is the identity matrix. So if you multiply any matrix with its identity, okay, you could manually calculate. You could manually calculate the inverse, right? The inverse for 2 by 2. It's gonna take you half an hour. All right. So if you like to calculate like the inverse for a matrix which is like 50 by 50, 100 by 100, 1,000 by 1,000. All right. So you have to have a computer for that. And the idea also that you could write a code for it, it would never be as fast. It's like this hundreds of times faster than your code you're going to write it back. That's the whole point. That's the whole point. It's the speed. Because you're dealing with the memory manipulation at the same time, right? So it's a very powerful tool. You could do a lot of things. A lot of things that you could do with it. Alright? Now we're gonna come for a graphic. The graphic I'm gonna cover like matplot. There's a whole section in graphing that we're gonna cover. A matplot. It's used for pandas. It's used for NumPy, for all of that. So we'll cover it when we cover pandas. All right, we cover pandas. So your job. What's your job? What's your homework? Okay, your homework to go through this tutorial from A to Z, try the codes. There's many functions, just I alluded you to, okay, but I will not go in details, play with it. I'll try to create a small exercise for you, let me call it exercise, alright, that uses NumPy, and try to play with it, alright? My goal in this class, not NumPy, is very useful to know, it's very useful to use it, by the way. I mean, although we're gonna go to the pandas in details, the rest of the chapter will go in pandas, okay? The only reason for that, because pandas is the package used for data science, means for machine learning and deep learning, alright? But pandas is not as good for matrix manipulation, it's not as good for solving equations, it's not as good for differential equations, it's not as good for statistical packages like NumPy and SciPy. So they have different applications, but at least by now you have enough knowledge about it that you could apply if you have pre-applications. Any question? Any question? Thank you so much. Have a good night.